We've got Jason Crawford on the podcast. Jason runs a blog called Roots of Progress, where he goes back in history and dissects a lot of pretty impressive human innovations that we take for granted currently. And he has some excellent pieces on the development of steel, development of vaccines, a recent one on some major public health improvements, actually cutting down the death rate from disease. And he had a piece that went pretty viral on the bicycle sometime last year. So those are all definitely worth checking out. And so in this conversation, we spend some time disabusing my high school self of some misconceptions about the nature of progress and what that actually means, and some common myths and issues with thinking about progress, as well as understanding how we can use history to actually help us sort of break through some current stagnation in our progress in science, in our progress in the economy, and all that kind of stuff. So this is a pretty good conversation. I think you'll enjoy it. Check it out. Right on. Well, so in high school, I was very much on the extreme political left, reading magazines like Adbusters and generally adopting sort of like an anti-corporate attitude toward the world. And I specifically remember watching a movie, some sort of documentary or short film in physics class where they were talking about progress and how progress can't be stopped. And I was so mad. I was like, progress sucks. We're destroying the rainforests. I hate McDonald's. I'm protesting, every other weekend in some capacity or another. I hate you. This is the stupidest documentary I've ever seen. And I probably wrote about it in a political zine that I had in high school. Convince my high school self that I am misguided.
Well, so that's fascinating. You say you had this idea of you had a reaction, progress sucks. Now, I've had people I talk to question, sort of, wonder and question, is progress really good? But I've never had anyone just outright come and say to me, progress is terrible. So it's funny because, from a certain standpoint, progress almost seems good by definition. So, what mindset do you think you were in that got you to say, got you to hate progress? What combination of ideas, led to that emotional outcome?
Yeah, this is going to be tough to really put myself exactly back in my shoes at that time. But I would say it was probably, at least part of it was sort of like you said, progress almost by definition is going to be good. So I sort of took progress almost as a euphemism for corporate exploitation of the environment and people. Right? Where it's like, oh yeah, no, we're making progress. And it's like, actually, you're putting up billboards everywhere and destroying the environment. That's not progress.
Got it. Okay, so you actually didn't believe in progress. You didn't believe that the progress, like what I would mean by it, you didn't believe that progress existed. You didn't actually think that things were getting better, that improvements were being made, that lives were being improved. I think that's the sad sort of state of of too many people today, that they actually have no idea in what ways the world has gotten better and is continuing to get better. And I think this is a gap in education today. We teach kids about history of kings and empires and wars that were fought. We teach them science, maybe, but we teach them the facts of science. We don't teach people, we don't teach people the history of technology, of industry. We don't teach them about the Industrial Revolution very much. We don't teach the history of science. How did we get here? And so I think many people just don't have a strong, vivid concept or any concept of how far we've come. So I was talking to somebody a while ago at a get-together who was kind of a progress skeptic, wasn't super sure about this thing. And I said, well, just compare life today to how life was in, say, 1700. And, can you think of what comes to mind when you think of the difference between those things? And the only thing this person could come up with was, well, I know medicine has improved. Like medicine's a lot better. Is that it? Is that the only thing you can think of? Right? That's actually like a tiny fraction of the overall progress that's happened, right? Just like the fact that we have heating and air conditioning, right? We have lighting that isn't literally burning things, burning candles and wicks inside our home. We have heating that does not create Smoke inside our homes, by the way, and in some parts of the world, smoke inhalation from indoor fires is like still a problem. We have mass manufactured products so that we can own like many sets of clothes, right? And we can actually wash them on a regular basis. Not to mention we can wash ourselves on a regular basis. And we can do so with hot water, right, that we didn't need to literally boil on the stove in a kettle, right? And it came out of a pipe instead of having to go and fetch it from the well. We can actually visit our friends and relatives and other places in the world if they are, far away, and we can we can get there in hours, not months. We can get there in relative comfort and safety, and that didn't used to be possible. If our friends or work colleagues or loved ones are far away, we can communicate with them instantaneously, any time of day or night that we want. We can see their faces, we can hear their voices, and in 1700, even in 1800, right, the best you could do was write a letter, and it would move at the speed that a horse or a ship, could move, right? And if your loved one fell ill, which used to happen a lot more, and they were on their deathbed, you might not get a chance to see them, right? You might not even hear about it until months later. If you were across the ocean, if you had gone to America and they were and your parents were back in Europe, by the time they get a letter to you that, oh, father has fallen ill, that could be 2 months later that a ship managed to make its way across the Atlantic.
Oh, father! Oh, father!
Yeah.
Oh no, father!
So you can go on and on with this. If you wanted to listen to your favorite music, well, you'd better know how to play the piano, and you'd better have a piano that you could afford, right? Or maybe guitar, or something you would have, right? And that wasn't something everybody had. If you were rich, you'd probably have a piano in your place, and then all the young ladies of the aristocracy would learn to play the piano just so that when they had a party, someone could say, "Oh, go play the piano for us," right? Because you couldn't put something on the stereo. Anyway, again, you can go on and on and on. So the simple basic fact is human life in almost every dimension has gotten orders of magnitude better in the last few hundred years. I've been focusing just here on dimensions of technology and wealth, kind of just practical living. But also, if you look at, say, our knowledge of science, virtually everything we know about in science about the world has been discovered in the last 400 years or so. And even in government and society, right, the one area that always feels like it's perpetually royally screwed up, if you think about it, in 1700, the entire world pretty much lived under monarchy, right? So we had absolute rulers as pretty much the only form of government that anybody knew. Now today, most of the world lives in some sort of I don't know if it's most. A large part of the world lives in some sort of representative democracy, and that is a huge change. So in all of these areas, in technology and wealth, industrial production, in science, our knowledge of the world, and even in many ways in government and society, we've just come such a long way. It was relatively speaking, it was a really terrible world to live in just a couple of hundred years ago. And the other really remarkable thing when you look at this fact is human beings have had higher level conceptual functioning for at least 50,000 years. Arguably, significantly longer than that. But I would say lower bound, we can say 50,000 years ago, there is evidence of early art and religion. It's the beginning of what they call behaviorally modern humans. So if we've had at least 50,000 years of that level of thinking ability, and yet almost all the progress we've made in all three spheres I just mentioned has happened in the last 500 years or less than 1% of that time. And so the bottom line from that is progress is neither automatic nor inevitable. It doesn't just happen on its own. For most of history, not much of it was happening at all. Right? A sort of tiny amount relative to what's happened in the last 1% of that time. And so I think when you look at that, if you care about human life and thriving and flourishing, human health and happiness, you just have to be a little awestruck once you realize the magnitude of what we've accomplished in those last few hundred years. And you have to start asking, how did we get here? Why did it take so long? And how do we keep this going?
Right on. So I'm trying to put myself in my 16-year-old mad at the world shoes to, just dismantle your seemingly great story. And I think that my thought process probably would have been maybe twofold in terms of thinking in terms of like zero sum, right? Meaning that if someone is winning, someone else is losing. And then probably also some sort of like pseudo Malthusian understanding of environmentalism, meaning that, human beings are sort of like the guppies that I had as a child, where if you overfed them, they would just eat until they die. Or, if you have too many, I actually think that experiment was discredited, at least partially, but there was a famous experiment about mice where, if you allowed them to just sort of do whatever, they would overpopulate to the point that they would destroy themselves. Right. And so I think that I probably had some conception of those two things, right? If someone is winning, someone else is losing, and that human beings are sort of like an out of control, growth-based species that is going to just grow to the point that we destroy ourselves and everything around us.
Yeah, sure. So let's take both of those. Let's take the second one first. So you mentioned Malthus. So your 16-year-old self, being worried about overpopulation essentially is in good company. Well, at least it's not the kind of idea that only a 16-year-old could believe, because there have definitely been some prominent adults who believe this as well. So sure, you go back to Malthus. So for those who might not know, Malthus wrote in the, I believe, early 1800s, maybe the very late 1700s. He was a reverend, and he wrote this article on, essentially he was saying, population growth is just going to lead to kind of perpetual famine and catastrophes of food. And his basic argument was as simple as this: population grows exponentially, or he would say like geometrically, and our food supplies, he said, can't possibly grow faster than linear. And so a geometric curve an exponential curve is always going to overtake a linear curve no matter where they start out eventually. And so we're going to hit a point where there's just not enough food for people. And that will put this, really harsh upper bound on the population. Now, to his credit, he was, the way he described the world was more or less how most of human history had been right up until that point. And what he didn't know, and perhaps can be forgiven for not knowing, is that the entire world was just on the brink of completely changing. And so what actually happened after Malthus wrote is that our food supplies did increase geometrically. They increased exponentially. And in fact, food and overall, wealth in general increased faster than population. So we got this thing where after hundreds of years, many centuries of just sort of population fluctuating and certainly income per population, never really going above a certain level, we suddenly got this completely unprecedented thing where both population and per capita income were increasing at the same time. So population's booming, and at the same time, our overall wealth is booming even faster. And it basically happened because of the Industrial Revolution, because we figured out how to apply science and technology and systematic methods of improving things and applying our intelligence to the problem of production and survival. We figured out how to do that, and we figured out the cultural and the institutional foundation for it, and it took off exponentially. So, Malthus, if you go back and read what he actually wrote, he really didn't have much of an argument for why food supplies couldn't grow, except essentially an argument from failure of imagination. I mean, he literally just says, you just can't imagine that we could possibly increase our food supplies more than linearly. I mean, come on. That was the essence of his argument. And again, maybe had some, maybe it was very reasonable historically, but turned out, because of when he wrote, to be completely wrong. Now, there's been more recent writers who have had similar fears. In fact, some people I think are still clinging to this fear of overpopulation. So one of the most famous was this guy in the 60s, I think Paul Ehrlich wrote The Population Bomb. And, he was concerned about the exact same thing. And people in the 60s and 70s were predicting, like mass worldwide famines coming. I think they predicted them for like the year 2000 or earlier. And here we are in 2020, and we've had, nothing like that. In fact, wide swaths of the poorest people in the world are getting wealthier. Incomes are going up in the poorest parts of the world, especially China and India over the last few decades. And so basically nothing beats the Industrial Revolution. It keeps going, it keeps providing, it keeps giving, and it keeps making everyone wealthier. So that's the population concern. So we can move to, you had this other notion of, is it really just for a few, right? What about, and this is a common concern you hear today. So what about inequality? The simple fact is that the Industrial Revolution has not benefited only a few. It's benefited the masses. It's benefited almost everybody. One of the sites that I love to go to for data and information on this stuff is a website called Our World in Data. Disclosure: I'm now doing a bit of work with Our World in Data, helping them improve their website. But I've been a fan of it since long before that. And one of the most amazing charts that you can find there is 3 curves of life expectancy. And I think they're roughly from like early 1800s, one from the 1900s and one from around today or very recently. And you can see it shows you life expectancy across the world. And what you can see from this chart is the places in the world today that are worst off in terms of life expectancy, that have the shortest life expectancies, still have a longer life expectancy than the places that had the longest life expectancy in around 1800 or early 1800s. So we've literally raised everybody up to the point where everybody today, or at least every country today, is better off than any country was about 200 years ago. And that's just one of the most striking, I think, demonstrations of the fact that this tide of science and technology really is lifting all boats.
And so one could make the argument, though, that let's say that everyone is getting better, but potentially that doesn't discount the fact that there could be rising inequality simultaneously, right? Even though everyone is getting better, inequality could be increasing. And it could also be that even if someone's, let's say, absolute standard of living has improved, if inequality has improved, that actually makes them less happy based upon their whatever comparative instincts. What do you think about that?
Yeah. I haven't looked into the literature on this, but I don't really buy the relative happiness argument. I think absolute well-being is more important than relative well-being, both in sort of actual fact and in terms of happiness. I think if that's not the case, part of what we should do really is help educate everybody to understand, where we all came from and how, if you want to compare yourself to something, compare yourself to the past, right? I think another thing is that there was a time in the West, and there still are places today, such as China, where progress is visible to people in a very personal way. They can see their lives getting better decade by decade. Parents and children can sort of compare their lives, and by the time you reach middle age, you can just see how far your world has come, not just the world. I'm not sure that everybody in the West feels that today, and I think many people don't, or they feel that things are stagnating or even worse off. And so, one thing I would like to look into is, why is that? And can we change it? Is it because of actual stagnation in progress in the West? Have things slowed down? Have they just gotten less visible somehow? But I think the more that we can do to keep progress rapid and make it visible, the more everyone will be able to see it very personally in their own lives. And that will, that along with just sort of general education, spreading the facts, telling people the numbers, I think will help make the case for progress.
So you mentioned earlier that behaviorally modern humans have been around for, what was it? You said 50,000 years?
At least 50,000 years. I mean, these numbers are always changing based on latest research.
Sure. But essentially, we had people who were more or less the same as us around, right? Similar intelligence, similar social customs, similar, networks of people that they're living in, maybe not with all the gadgets that we have, but a lot of very similar dynamics. And those people were not making any progress. And you mentioned that most of what we would consider to be progress has been in the last 400 years or so. What do you think was actually the tipping point that caused this takeoff in progress to happen?
Yeah. So to be fair, there was extremely slow progress. Behaviorally modern humans did invent a number of things. They invented better stone tools, more specialized stone tools, right? They had bows and arrows. They had small boats and clothing, right? So at least from animal skins. So there's all kinds of things like that. They had some things. It's just these inventions were probably spaced out hundreds to thousands of years. Today the pace of invention and innovation is obviously much more rapid. So you say, okay, what was the tipping point? Stepping back, like really broadly, I think of human technological history in three broad eras. So maybe there's two tipping points. The first era is that first, roughly 40,000 years ago of tribal kind of pre-state nomadic hunter-gatherer societies, pretty much Stone Age. Then there's a huge tipping point is kind of the advent of settled societies, agriculture and crafts. This gives us, the beginnings of what we would think of as civilization. And then that gives us an era that is dominated by agriculture. Eventually, sees the rise of states, mostly monarchy, a feudal system, and then a few hundred years ago, we get another tipping point where we transition to a world of industry, science, technology, the Industrial Revolution. So I think of, again, three broad areas: kind of the hunter-gatherer phase, the agriculture phase, and then the era of industry. So the two big tipping points would be the ones in between there. You might add in the middle. So in the middle of the agriculture era, we got writing, and writing was absolutely crucial as well. So you might put a small dividing line in there.
And so if you think about these different eras, one of the key aspects of actually creating new inventions is recombining ideas, right? Is like actually taking an idea from one area and applying it to somewhere else, then being able to kind of trade up rapidly in terms of what you're actually working on, right? So one can imagine that there's some sort of virtuous cycle that gets started that does result in these kinds of tipping points. And you mentioned that previously, this stuff doesn't happen necessarily by accident. It's not a foregone conclusion that we're going to hit these types of abilities to like quickly start iterating on new ideas and recombining them. What do you think is the actual catalyst that causes this type of runaway effect?
Yeah. So I don't yet have a grand unified theory of human progress. I don't have the final answer for you, but I've definitely got some thoughts I can share. I think one of the most important things that changed and that ultimately led to this era of increased progress was the very idea of progress itself. So read a very interesting book at the beginning of this project called A Culture of Growth by an economic historian named Joel Mokyr. And Mokyr points out that the very idea of progress, the idea that progress is possible and desirable, is a relatively new idea in history. So for most of human history, we were dominated by the opposite, by what Mokyr calls ancestor worship. So this is the viewpoint that essentially our ancient ancestors, our distant ancestors, were the greatest people who ever lived. They were the wisest. They knew everything. Really, all knowledge was revealed to them in ancient times and passed down to us through the sacred texts. And really, we can never surpass them. We can never even equal them. We could never hope to do things greater than what they did. All we can do is kind of try to soak up as much of the knowledge that they have to pass on to us as possible by reading and rereading those ancient texts and kind of deeper and deeper levels of exegesis to wring more and more, meaning out of them. But that's all we can do. And this attitude was dominant for most of human history. Mokyr says that it started to change in the West between roughly Francis Bacon and Isaac Newton. So, roughly the 1500s and 1600s. One of the first cracks in this, he says, actually was the voyages of discovery that began in the 1400s. So, with the voyages of discovery, we started sailing ships across the ocean and around whole continents, finding new routes in navigation. And, of course, in 1492, the West discovered an entire new continent that it was not previously aware of. And so, this made people realize, well, wait a sec, this continent was not known to the ancients. So I guess not all knowledge was revealed to them in the ancient days. Maybe there's something new that we've discovered, something that we the moderns have added to the knowledge of the ancients. And this went on. In fact, there's a whole running debate about it, the ancients versus the moderns. The final nail in this coffin, really, Mokyr says, was Newton. So when Newton came out with his system of the universe, his theory of universal gravitation and how that explained the solar system and everything, this was clearly such an achievement, such a much better way of understanding the heavens and the universe than anyone before had ever come up with, that it just settled the question. And after this, many people from a surprising variety of disciplines were inspired by Newton. I mean, even engineers building water wheels and towers and bridges were inspired by Newton. Epidemiologists or the equivalent in the 1700s who wanted to understand how disease spreads were inspired by Newton. They looked at what he did and how he used math in particular to understand the world. And they were looking for all sorts of ways to apply better systematic experimentation and quantitative methods to understand their little corners of the world. So I think this idea of progress and discarding the idea of ancestor worship, which is a tough thing to do. Mokyr says that invention, in a certain sense, is kind of an insult to your ancestors. Because to come up with anything new is, in a sense, to turn around and say to them, well, I've come up with an idea that's better than anything any of you in all the past generations ever imagined. But that's what we do, right? And it's, of course, because we do stand on the shoulders of giants, and we make progress going forward on what our ancestors left to us. So really, it's at the end of the day, it's no insult to our ancestors, but it can feel that way, certainly to those who are sort of steeped in this concept of ancestor worship. So I think that concept was crucial and was one of the biggest tipping points that actually led to the scientific revolution and the industrial revolution.
Sure. So this idea of transitioning out of ancestor worship and into understanding that, current people may be able to figure out more than previous people had sort of kickstarted a lot of innovation across the board. Do you think that there's any relationship there to any sort of broader trends just in like a big picture level, as opposed to saying, oh, you know what, Newton discovered all this stuff and was clearly a genius? I'm thinking, for example, have you seen any of the research on weird psychology and the Catholic Church?
No.
So I'll give you a quick breakdown of this. I am unqualified to have an opinion on how valid it is, but it's a fascinating idea, right? But essentially, the basic rundown is that people from Western, educated, industrialized, rich, and democratic countries have a totally different behavioral profile and understanding of the world than everyone else. And essentially, the way they think about the world is simultaneously more individualistic as well as more trusting in large-scale institutions. And what they aren't as much of as the rest of the world is sort of like clannish and nepotistic. Right. So they're more willing to sort of strike out on their own and do stuff, but they're also less willing to kind of like break the rules of the overall system in order to like help themselves or their friends. Right. Whereas the rest of the world kind of operates in this like, OK, I have power, so I'm going to give my people, power also. And we're going to kind of band together in our clan and take on other clans. And there's a theory that this sort of grew out of the Catholic Church banning cousin marriage, because it sort of disrupted this sort of incestuous clan creating system, which then allowed people to kind of sort of bifurcate their loyalties to themselves and then to like the big picture institutions as opposed to their sort of overall clan. And again, it's super interesting. Sounds like the type of thing that is probably very controversial, and people who are actually well-versed in this field are probably like, no, it's bullshit for this reason, et cetera. But I'm wondering if you have any thoughts on, was there some sort of larger scale social thing going on that could have facilitated this type of innovation?
Yeah, certainly. So now that you mentioned that, I have heard of it, although I haven't dug into any of the actual presentations of it. The notion that I'll just broadly say Western culture is sort of more individualistic, but also more wants to follow the rules of the system versus others makes sense to me. Tracing it back to cousin marriage seems implausible. So I would say this is really more of a consequence of the Enlightenment and the focus on reason. So in Steven Pinker's book Enlightenment Now, he talks about how part of the adoption of reason in more fields and forms of human life was one of the consequences was a drive towards universalism. So the notion that we need that valid rules, whether of institutions, of morality, or whatever, valid ways of looking at the world are universal ways. And that if your viewpoint is not one that's sort of valid for all human beings, then it's not a valid or ideal viewpoint. And I think this is part of what led away from the clannish or sort of very localized view of things to something that encompasses ultimately all of humanity. Pinker ties it to ultimately the abolition of slavery, right? Seeing other peoples as equal to your own people, and therefore whether that's or other races as equal to your own race, and therefore we need the same rules for all of them. He ties it to the other rights movements, civil rights, women's rights, etc. And that is a compelling explanation to me. So if you look at you're looking for big picture trends and kind of and very long-term trends. I would say the big long-term trend that you see in the West, at least in Europe, and then by extension in America, is from we had this period of the Middle Ages which were very focused on religion and very religious period and very otherworldly, very focused on the next life, not this life. Not very focused on looking at the world and understanding the world. And there's a sort of gradual transition out of it, helped significantly by the rediscovery of Aristotle in the 13th century and his promotion by Aquinas. And the period after this was known as the Renaissance. The Renaissance is the rebirth of reason and of really turning back to the world itself as an interesting area of study, and not only the world but mankind, sort of humans looking inwards, so taking their eyes maybe away from God 24/7 and thinking about salvation and the next world and heaven or hell, and bringing their thoughts back to understanding humanity and understanding this world. Another phase of that was with Francis Bacon and others like him promoting an experimentalist view of how to gain knowledge, wanting to do experiments, systematic observation, and then with Newton and Galileo and others bringing mathematics into the equation, so we started getting quantitative about measurement. And then I think after that, and certainly after Newton, you're in this period that we call the Enlightenment, where really reason was getting applied to every sphere of human life, and science was surging forward in this scientific revolution. That's a really brief and very rough recap and of about 1,000 years of Western history. But I think that's kind of the broad sweep and the broad strokes of kind of coming out of a very religious, dark and Middle Ages, and then gradually working our way towards a more earthly and reason-focused and ultimately people-focused, human-focused approach to science, technology, and ultimately government.
So to get maybe more tangible with some of that stuff, then you've done some excellent pieces on the blog, which we'll link to, on the invention of the bicycle, a breakdown of steel production and development, as well as the development of the smallpox vaccine. And all of those are great pieces and well worth the investment to actually read through them. But do you have anything that you found particularly insightful from your research and your writing on that? Not just, okay, well, here's the history of it, but what can we actually learn from those, let's say groundbreaking inventions?
Yeah, certainly. So on the Roots of Progress, my blog, I am taking a very bottom-up historical empirical approach to this whole topic. We've been talking about some pretty big picture stuff, but I actually think it's a little dangerous to speculate too much about the big picture before you understand the story on the ground. And so in the blog, I've been focusing on some stories that are very much on the ground, the through line of like a single, relatively narrow technology, which these stories themselves are fascinating. And so it's really interesting to dig into, how did the bicycle get invented? What phases did it go through? Or, what is this material called iron? And what is steel? And how do those things relate? And where do they come from? And so, I've written on a number of topics like this. But I also, with every one, I try to take a look at, what are the lessons? Or at least, what are the themes that this particular story hints at? Maybe we don't have all the answers yet or a completely worked out theory, but we can certainly start to see broader themes in each of these stories. So, for instance, with the bicycle, I got interested in the bicycle not because the bicycle is a particularly crucial piece of industrial technology, or even because I'm particularly fond of bicycles. I got into it because it seemed like this striking case of what Alex Tabarrok calls ideas behind their time. You've heard of ideas that are ahead of their time. There's some ideas that are behind their time, which is when the idea comes along, you sort of wonder, well, why did it take so long? Like, why didn't we have this idea decades or centuries ago? And with the bicycle, I was sort of thinking about, okay, bicycles didn't really come along until like the late 1800s or so. Why was that? Why didn't we have bicycles in, the Roman Empire? Why didn't we have bicycles in ancient Greece? It seems like, it's a mechanical invention. It's not as if it rested on some theory of chemistry or electricity. It's pretty obvious why we didn't have, say, the telegraph until the mid 1800s. So we didn't figure out electricity until the early 1800s. Right? The physics behind it just wasn't there. But the bicycle doesn't seem to rest on any such theory. So I asked this question on Twitter originally. Just put this out there. Why didn't we have bicycles until the late 1800s? And people replied with all kinds of theories. And I was so intrigued by all these different theories. It was precision machining. It was rubber for the tires. It was roads. We needed roads first. It was horses. Horses. People could ride horses, so they didn't need bicycles. Turns out a lot of these theories don't really hold water, especially when you look into the actual history of it. So I looked into the history of it, and I wanted to get at this question of why did this thing come along so late? And so, with the bicycle, there's some answers, and if you read the post, I get to some of these things towards the end. Part of it is just that the proper design of the bicycle is actually a lot less obvious than you might think at first. From the very first bicycle-looking prototypes to what we would recognize as the modern design of the bicycle, it's about 70 years of design iteration. It took most of the 1800s to figure this out. There also were some, mechanical materials and manufacturing innovations that were probably necessary to get a mass market bicycle that was actually practical and affordable, although they were not necessary for the earliest prototypes, which, by the way, the earliest prototypes of bicycles were made out of wood with iron rim tires. So you really didn't need anything other than, ancient or medieval technology. But I don't think any of these can really be the deepest explanation because, as I pointed out towards the end of that post, you can actually ask a very similar question about a number of other technologies. So I asked it in an earlier post about the cotton gin. The cotton gin is really even simpler than the bicycle. And economically, it's much more important. The cotton gin as an invention transformed the cotton industry, certainly in the American South in the late 1700s and early 1800s. Why wasn't it invented until 1793? There's really no good reason that I know of, except if there is some kind of general. So I'm coming back to this idea of progress, the very idea of progress. I think for a very long time, it just didn't occur to most people to tinker and experiment and invent and to actually try new things. And the ones who did have that inventive spirit probably got sucked into like alchemy or something, a lot of dead ends, trying at goals that were actually like way too difficult. It's funny to think about what were the goals of the alchemists were like transmutation of elements and anti-aging, what we call today, right? Eternal life. Those are still today goals that are outstanding that we haven't solved yet and that seem pretty far in the future, right? So I think one of the mistakes that the alchemists made was just trying to get to this like amazingly far future goal in like one shot, right? And so they were just like tinkering around with trial and error to try to, tinkering by trial and error is a great way to get incremental progress, but you actually have to pick a goal that is like a next goal that is just close enough that you can actually get there by tinkering along with known things. To get to very far future goals, you actually need to build up kind of more systematically an entire structure of science and innovation.
Although Newton was into some pretty goofy stuff, and that didn't stop him.
Oh yeah, sure, but he didn't get anywhere with alchemy either, right?
Yeah.
he the experiments of his that actually worked were things where he could actually one person could actually get there in one shot.
So circling back to this idea of ideas behind their time, I wonder if there's something related to almost like you said, if certain problems are more resistant to tinkering than others, in terms of there needing to be some sort of combination of insights all at the same time that result in the thing happening. Right, where it's not an easy recombination of two disparate ideas that just requires someone to see them, nor is it something that you can kind of like iteratively tinker to get by making gradual improvement. You have to get, let's say, 6 different things all to happen simultaneously in order for the idea to work. Otherwise, it just fails. Have you thought through any of those ideas?
Off the top of my head, I would say, so generally when you find that something, needed 6 things to work, like very often the way it happens is, honestly, the same way it happens in biological evolution. It turns out there's some intermediate value to having just one of the things. It's not the ultimate value, but there's some other value to having just one of the things. And then there's like a different incremental value to having the second thing, and a different to have the third. And so they actually do build up kind of one at a time. Now, of course, humans can be much more directed and conscious about the evolution of our technology than biological evolution, which is blind in a sense. So another way that things can happen is if there's a goal that is big enough, we can have, and occasionally we do have, a huge, a massive effort by many people with lots of money poured into it over a long period of time to actually make some big thing happen, right? We've got, Manhattan Project-like efforts. And so I think that is the kind of thing that lets us maybe get beyond some of the constraints of a purely incremental, evolutionary thing. But there are some things, of course, that there are some goals that are just too far away. Again, for the alchemist, transmutation of elements was just too far away to try to get there through pure tinkering, pure trial and error with absolutely no science, with no idea of chemistry, no idea of subatomic particles, no physics. You just can't do it, right? And so I think if you really want to understand progress, technological and scientific progress, I think one key thing to understand is that technology and science exist together in a reciprocal relationship. Science is constantly moved forward by technology, and technology is constantly moved forward by science. And the notion of tinkering versus having science or theory, it's actually a bit of a false dichotomy. I think both tinkering and theory are generally applied in most innovations, both in science itself, moving knowledge forward, and in technology, moving inventions forward. And very often what happens is that the scientific or knowledge or theory in general sets the context and the framework in which we experiment and go through trial and error and tinker. And so I think it's actually wrong to like draw a kind of dividing line between these things and pit them one against each other. They actually they work together and they feed back on each other in in a cycle, in kind of an upward spiral of knowledge and innovation.
Yeah, I think you see similar stuff in any type of skill acquisition context as well, right? If you think about, okay, you have to know, we could use something like computer programming, or you could use something like playing a sport, where there's probably some value in having a theory about what you're doing and, reading a textbook on computer science or watching film and listening to a great coach explain something. And then there's also theory in like just straight up doing, or value in straight up doing drills, right? Like, okay, I'm going to go and I'm going to kick the soccer ball against the wall and try to learn to trap it in this scenario, or I'm just going to do like little toy problems in my textbook to sort of like drill this specific way of creating functions. And then you have to actually do the thing though simultaneously. And that by doing it, you ideally integrate the theory in the drills. And then simultaneously, when you're doing it, you potentially notice little inconsistencies or problems that then you need to solve. So then you can go back and do drills or search out new theory to then answer the questions that you're developing based upon putting the theory into practice, so to speak.
Yeah.
So if we think about the ideas of progress, right? I mean, you've laid out a pretty compelling case that we are in fact making progress, and that is not in fact, despite my teenage concerns, a bad thing, in violation of the definition of the word itself. But some folks have made some pretty compelling arguments as well that we're in a period of stagnation, right? Folks like Tyler Cowen, Patrick Collison, and Peter Thiel in particular have all put out some interesting interviews and articles, et cetera, saying, you know what, we're actually stagnating more than we realize, that we're not making progress as quickly as we quote unquote should in scientific fields, that economic growth is not growing in the way that we would potentially expect based upon a lot of the developments of new technologies and various software companies. So something is going wrong. What do you think about this? Do you think we are in fact stagnating more than we potentially realize?
I don't know. I have not yet made up my mind on this issue. I think so first off, I think everyone would acknowledge it's pretty difficult to measure. Tyler Cowen and Ben Southwood came out with a paper recently kind of surveying a lot of what's been done here, and they make some good arguments, but it's very difficult to measure. Generally, you look at things like for economics, you look at things like GDP growth, but everybody knows that GDP doesn't capture exactly the same thing that we think of when we think of progress. So now you start to argue, is there mismeasurement? Cowen and Southwood had some good points in the article about like, well, if you're going to argue that mismeasurement accounts for the slowdown in GDP growth, then you'd have to argue there's more mismeasurement now than there was in the past, and that's not clear at all. So I guess my bottom line at this point, not yet having reviewed everything that everybody has to say about this, is I think I've seen some compelling evidence that there's been at least a bit of a slowdown, but I don't know for sure, and it's a little unclear to me how much of a slowdown it is. Certainly, any slowdown is concerning. I think if when you understand progress and the moral imperative that it truly is, I think you want to keep it going as fast as possible. In fact, you want to accelerate it. We actually want to speed it up if possible. So, you ask, why might it be happening? Again, I don't have the final answer there either. We can talk through some ideas. Certainly. One idea that's been put out there is kind of a low-hanging fruit type of idea, that maybe we picked all the low-hanging fruit, and so now the what's left in terms of more progress to do is just more difficult, just sort of inherently more difficult. I can certainly see that in science. So if you look at scientific progress, man, a couple hundred years ago, there was a time when you could literally be playing with magnets on your kitchen table and discover fundamental new laws of physics. I mean, I'm exaggerating a bit. Maybe you needed some better instruments, or you certainly needed a prepared mind. But today you look at what's pushing the frontiers of science today, and it's these enormous projects like the Large Hadron Collider at CERN, or the LIGO, the gravitational wave detector, and these are huge projects involving hundreds, thousands of scientists, decades of time, massive engineering projects. Just because, we're at this, we've pushed the frontier so far, right? So I think that is there's a pretty good argument there that there's just in science at least we pick the low hanging fruit. Is that true in technology? I don't know. Another way to look at it is so one thing I think about when I think about progress slowing down is like, well, if you break progress down into progress when you back way up looks like a kind of a smooth like exponential curve, but when you drill into it and look at its component pieces, each piece, each kind of thread each avenue within progress is more of an S curve. So it starts off slow. Some particular technology, whether that's the steam engine or mass manufacturing, or oil or electricity or plastics or computers, starts off slow in this kind of era where it's still getting researched and figured out and implemented. Then it hits this accelerating curve, goes through a very rapid expansion where it gets deployed to the whole world, and eventually it hits a point of diminishing returns where it starts to level off. I mean, it can't just exponentially grow forever. Any individual technology, eventually we've kind of figured out all the things we're going to do with it. We've deployed it to the whole world. There's just not that much more to do with it. So there's this kind of S curve as it's described. And if you look at what's the big where most innovation has been the last number of decades, and where a lot of wealth has been created, has been in computing technology, computers and the internet, and that arguably was kind of on the soft or the very beginning of the S curve in the middle of the century. Computers weren't even really invented until the 1940s. They weren't commercialized until the 1950s. The microprocessor didn't exist until the 1970s, right? Then in the 80s and 90s, certainly they start to get on that really steep part of the curve. Arguably the 2000s and maybe even now, we're still pretty steep. But we're about at the point where, historically speaking, I mean, these waves tend to go in like 50 to 70 year cycles, I think, if you just look historically. So we're at the point now where it's kind of to be expected that computing curve is starting to level off. And so you can imagine, okay, that progress has slowed down, but really maybe we're just waiting for the next wave to come along. We're really just waiting for the next S curve to take off. Maybe that will be biotech. Maybe it will be genetic engineering. Maybe we will look back on the discovery / invention of CRISPR as an early trigger that led to much more rapid knowledge production, and in a couple of decades from now, some really amazing products and technologies. The counterpoint to that is to say, yeah, but how did we get into this state where we're only relying on a single S curve? In the past, you can see times when actually we had like multiple S curves overlapping and kind of all going on at once. And so how did the S curves dwindle, down to just one? Like there was a time when maybe, oil, like the internal combustion engine, like plastics, mass manufacturing, antibiotics, there are like maybe a lot of inventions, early electronic communication, like a lot of that stuff was going on in the early 19th century. In the early 20th century. In the late 19th century, you had you actually had the beginnings of the oil industry. You had the beginning of the electricity industry, the first electric, lights and generators and motors. You had all kinds of things, right? The telegraph and the telephone. So how did we get down to just just one S curve? Maybe that's the real thing to look at. I don't know. I don't have all the answers here.
Yeah, I'm also curious, to your point earlier, it's difficult to tell what's actually going on. And I feel like the numbers are difficult to analyze, and you can probably make a lot of arguments as to whether or not they're valid based upon what they're measuring. And, I'm certainly not well versed enough in a lot of those areas to have a strong opinion about that. But something I am curious about is the internet itself seems to me like it should have generated more progress and potentially kicked off more of these other S curves, right? Based upon these ideas of connecting more people, making ideas accessible, putting a lot more, let's just say, brains online with world-class knowledge at our fingertips to be able to, recombine ideas and learn physics and come up with new developments, or have different technologies that we can, utilize and trade and all those kinds of things. But it seems that the rise of the internet has almost correlated with this stagnation, which seems like the opposite of what should happen. What do you think is going on there?
I don't know. Anecdotally, that what you hypothesized is absolutely happening, right? We can see it in things like Khan Academy. Certainly, within the tech industry, which I was part of for the last 18 years or so, the difference in how much knowledge there was about, say, how to start a technology startup, what you could learn about that in like 2001 when I graduated versus what you can learn about that today is just like there's just an amazing wealth of knowledge out there. Mark Andreessen says that a kid almost anywhere in the world who has like a cell phone that has access to the internet can learn more about startups than he was able to learn being at like UIUC in the 90s. Right. So someone who's much farther from the center today can actually learn much more rapidly and easily. Why isn't that turning into GDP growth? I don't know, but there's many steps in between, a kid learning a skill on YouTube and GDP growth. And then again, remember, so part of the problem with GDP growth or with GDP as a measure is that it doesn't actually capture all of the, all the consumer surplus from something like YouTube, right? The fact that if I go and I learn a skill on YouTube rather than paying a contractor $100 to do it, that actually generated a huge amount of value for me. That doesn't show up in GDP. In fact, it shows up as negative because now the $100 I would have paid the contractor gets taken out of GDP. So again, this gets you into deep arguments about GDP measurement and mismeasurement and so forth. And I won't I don't want to make too strong a case that it's all
right. Yeah, because Reid Hoffman would say. Oh yeah, well, guess what? Then you would have applied that $100 elsewhere, so it is accounted for. Or wait, I actually don't remember if Reid said that. Someone said that, but you can just like keep going back and forth and keep trying to nest the argument inside itself. I don't know.
But let me mention some other some other angles on the problem of kind of where, if there's stagnation, like where is it coming from? There's cultural and political angles, right? So like Tyler Cowen has hinted at least at. Is there just sort of a general, bureaucratic stultification of some of our institutions, such as academia? Maybe business is the same way in some ways, and I think that's entirely possible. Certainly, there seems to be a kind of ratchet on bureaucratic rules that rules and institutions and processes and things get put in place when when some kind of a scandal or disaster or catastrophe happens and people get hurt by a thing, and then they put new rules in place to prevent that thing or to guard against it. And the new rules almost never get taken away. And so you get this kind of slow ratchet of, increase in rules and process and bureaucracy. This seems like off the top of my head, at least, seems like a good hypothesis for instance, why can't we actually do construction as nearly as fast as we used to in the United States, right? This is a favorite topic of mine and also of Patrick Collison, who maintains a page on his website called Fast, which is just literally about how we used to be able to build things super fast. The Empire State Building famously went up in like a year or just over a year. The Golden Gate Bridge, I think, was super fast. There's all these different things. One of the hypotheses that I think about a lot, and I don't know how widely this hypothesis is favored, but I think a lot about just the cultural and almost moral narratives around progress. And I think that, I think that 50, 70 years ago and earlier, the general public was like a lot more favorable on progress, had a much better, more optimistic view of it, a more optimistic view of the future, a more kind of heroic view of scientists and inventors, and even some industrialists, although that was mixed. And I think, since around the 60s or 70s, our view of the future has been, transitioning from a utopian one to an increasingly dystopian one. And I think your view of the present and the future that you had as a 16-year-old in high school is just indicative of this, right? And there's a reciprocal relationship between our views about progress, our idea of whether progress exists and whether it's good and desirable, and the progress itself, right? So like the more progress we make and the better it's possible, the more everybody sees it and believes in it. But also, the more people believe in it, the more they're going to actually work to bring it about and make it happen. And so I worry that, some of the best minds of our generation are actually getting turned away from endeavors that actually would drive things forward because, it seems like that's just a commercial endeavor. That's just making money. That's just joining the rat race or something. And, and maybe they turn to something else. But in order to continue making progress, we have to continue to, let everyone know that progress is actually possible and desirable. And, it needs to be a thing where people are personally, individually motivated and inspired to go into fields where they can help drive the world forward. And then, to have that ambition and to pursue it with vigor and energy. And so I wonder whether we've lost some of that in the last, 2 generations or so, and whether that's contributing.
Yeah, totally. It could totally be like the bigger picture cultural aspect. It could be the overall, thick red tape bureaucracy. Related to the bureaucracy, something else that came to mind was the almost by nature political relationships within large organizations that come out at a certain point, right? It becomes more valuable for you as an individual to play a certain type of political game within an organization than to actually try to push the overall goals of the organization forward. And one would think that would sort of get sorted out in the marketplace and that, potentially people would move to firms that don't have those issues or to institutions that don't have those issues, or that, firms and institutions would be able to compete against each other better or worse based upon their size and what they're trying to accomplish. But there may be another layer there as well of not just bureaucracy, but the incentives for people being, okay, I need to engage in certain types of politics in order to do this, which could potentially stifle innovation, or to your point, put people off from, who would have the capacity to innovate from even participating in, let's say, a large academic institution where they're like, this whole tenure thing is so stupid and I don't want to fight over grant money. I'm just not doing this. Yeah.
And, in business and industry, there's a relatively healthy, regular turnover of companies, right? Companies, it's compared to, say, government or academia, it's relatively easy to start a new company. And so lots of experiments get tried. You have lots of clean slates where companies start out with, without a lot of bureaucracy and politics, and some of them manage to stay relatively healthy as they grow, although all of them get, a bit of bureaucracy and politics. But if something gets really stultified, then, eventually they're just going to get obsoleted and replaced. Unfortunately, it's not nearly as easy to do that in, some other areas. So in academia, in government, there's just, there isn't that kind of like regular competition and growth and replacement. And I don't totally know why in some areas. So, academia, for instance, this is another thing that I think Cowen and Collison have talked about. Why is it that there have been, if you look at the top universities, they're all like 100 years old at least, right? If you look at the top companies in the world, they're nowhere near that old, right? Why do we have such, much better, I dare say, healthier turnover in companies and corporations than we do in universities? Why is it so hard, it seems, to start a new top-tier university versus starting a new, top-tier company, which seems to be relatively much easier? In government, the answer is a little clearer. It's, we sort of deliberately make government hard to overthrow, right? And some of the effective ways to overthrow governments are pretty violent and destructive, and we actually don't want to do that very much, right? But even there, it seems it's hard to make change happen, right? Our two major political parties, although they've gone through evolution, they've been pretty much the same two for well over 100 years now, right? 150 years.
Yeah, within academia also, at least intuitively, it seems like status is almost entirely tied to historical prestige, right? That there's, in other areas, you can sort of see both, where some people feel increased status from being on top of like the new trend in, say, music, but some people get, a increased status from being on top of like the classics or some combination of the two. And there's probably similar things more so in industry where it's like, yeah, it can be cool to work for this, classic prestigious firm that has been around forever, but it's also cool to be part of a startup that just got funded by Y Combinator. But, within academia, it's not cool to go anywhere other than the most famous institutions that have been around forever.
Yeah. Yeah, I think that's part of it, and so maybe part of the issue is that academia sort of operates on a prestige economy, whereas business operates on a money economy. Maybe that's part of the difference.
Yeah, it's very interesting. I think that but I feel like those perverse incentives in academia have existed back when people were churning out groundbreaking discoveries every few years, also, right?
Sure, and I mean it's not as if people aren't working hard to make more groundbreaking discoveries. That's absolutely still happening. So I wouldn't, I certainly wouldn't blame today's physicists, for example, that they aren't coming up with. I don't think the physicists are sort of slacking off. I don't know, maybe I'm wrong, but I have no evidence that the physicists are slacking off, and that's why we haven't gotten as many like new fundamental laws and theories of physics in the last 2 decades as we did, say, in the 1800s.
I know a physicist or two, and they're definitely slacking off. Hopefully they're listening to this. Being called out personally. Too much working out, not enough science.
All right, guys, come on. Human progress is waiting on you. Hurry up.
Yeah, it's much more important. So what are you currently studying? What's the next? Because I really like what you said previously about really trying to understand the ground level, bottom up development of ideas and what we can then potentially learn from that. So what's the next item?
Yeah. So the last couple of months, I've been very focused on history of medicine and in particular the conquest of infectious disease. I wrote a history of smallpox and the origins of vaccination. I am working right now on an article where I am actually digging into some of the academic literature that looks quantitatively at this issue, looks at mortality rates over time. What data we have on this going back as far as we can. Some data goes back to the maybe to the 18th century. And looking at can we figure out what actually quantitatively caused the decline in mortality rates, and from this come up with some sort of quantitative understanding of which of the various weapons, techniques, tools, technologies against disease, which ones actually made the biggest difference. And I definitely found some things in that research that were surprising, or not what I thought going into it. So I'll have that article coming out soon. After that, I'm going to be moving on to some other areas.
Before you do that, you gave a big teaser there for the post, but you have to at least let us know one surprising thing you found.
Yeah, sure. So I'll give you the hook, and then people can read the article when it comes out. But the hook is basically if you read if you read histories of medicine, the things that really stand out, the two techniques that stood out the most to me when I was just kind of reading histories of it, are antibiotics and vaccines. These are two techniques that are dramatically effective and also apply to a wide variety of diseases. And so they just show up a lot, and they kind of get the spotlight in the history. But when you look at the data and you look at the mortality rates, what you realize is that mortality rates from some diseases were dropping as early as the mid-1800s. And overall mortality rates, we don't actually have cause of death broken out for every area going back very far, but overall mortality rates in some parts of Europe were dropping, I believe, as early as 1670. And so, antibiotics weren't invented until the 1930s. Vaccines, other than for smallpox, were not invented until the end of the 1800s, and weren't really in widespread use until the mid 1900s. These techniques, these technologies that came around in kind of the early mid 20th century cannot, just in logic, cannot account for the reduction in mortality that went on for decades or centuries before that. So what was it? It must have been something else, and there's a number of different hypotheses, and so that's what I'm going to go into in the post.
Awesome. That sounds delightful.
And then after this, I'm going to turn my attention to another topic. One thing I am really eager to dive into is agriculture, and more generally, kind of food technology. How did we solve the problem of feeding ourselves? How did we end periodic frequent famines? How did we figure out how to preserve food and transport it all over the world? And I think there's so many fascinating questions there. But I might go into another subject first because I've found a question that is just really intriguing me. I've been reading David McCullough's history of the Brooklyn Bridge, and there was a footnote in this that blew my mind, where he said that in the 1870s, roughly 40 bridges per year collapsed in the United States. And this represented, I think he said, about 25% of the bridges that were built. So this blew my mind. Now think about this. There's almost a bridge collapse every week, right? If bridge collapses were national news, right, you had a national newspaper, you could just have like a Sunday bridge collapse section where you detailed all the bridges that collapsed the past week, and you'd usually have something to talk about. And this is just mind-blowing. It's like, by the late 1800s, we still hadn't figured out how to build bridges that could actually stand up for long periods of time under, all the shocks that they are subject to. And so that's really amazing to me. I don't know why that was, and I don't know when we figured it out, right? I'm pretty sure we figured that out. I don't think our track record on bridges is still that bad. But when did that happen? How did it happen? And how do you build a bridge anyway, right? Like, that's a pretty amazing feat, especially across some of the deep gorges and wide rivers that humanity has bridged. Just start to think about how you would do that, how you would put the very first timber or iron structure in place, and how do you hold the thing up? And it's just a fascinating set of problems, and so that might be the next thing I dive into.
Yeah, totally. I often use the bridge building metaphor in coaching people, right? Because if you're working on something and feeling like you're not making progress, but you might suddenly be able to do a new thing at some point, it's sort of analogous to building a bridge where it's like, hey, you're doing all this stuff, but it's not working. But at some point, you're going to be able to drive a car from here to here, and you just don't know when it's going to actually be. So love it. I'd love to have a real understanding of how to build a bridge as opposed to a fake understanding to, get some buy-in for people on doing hard stuff.
Awesome.
So in terms of posts as well, I mean, you mentioned a few. Is there any one in particular that you would like people to read if they have enjoyed these discussions on progress?
Yeah, sure. So if you just go to the front page of my website, I kind of list my top, 10 or 12 posts, the ones that I consider to be the best kind of long form, most well written and thought out. That's definitely where I would start. The smallpox one you mentioned is up there. A couple of more, high level or philosophical ones are there. One of my favorites that I wrote early on is titled Smart, Rich, and Free. And that's the basic case for why progress matters and why we need to study it. After Tyler Cowen and Patrick Collison put out their article in The Atlantic last summer about calling for this new discipline of progress studies, there was another kind of round of in various blogs of reacting to that and talking about progress studies. So I have a couple of those articles. But I would really encourage people to take a look at whichever specific technology is most motivating to them. I've written one on navigating the high seas, how we figured out how to maritime navigation and in sailing, how to figure out where we are and where we're going. I wrote one about the war of the electric currents between Thomas Edison and George Westinghouse in the late 1800s, and why we ended up using alternating current for our power grid and not direct current. Even though the world famous, much renowned Thomas Edison favored direct current, turns out there's fundamental laws of physics and economics that lead to alternating current. My summary of Thomas Hager's book, The Alchemy of Air, was one of my favorites and one of my early posts. That's about something called the Haber-Bosch process, which is maybe the most underappreciated industrial process in the world. Almost nobody knows what it is, but it basically keeps half the world alive by providing synthetic fertilizer to actually drive the world's agriculture. So all of those are some of my favorite posts, and they're all listed right on the front page of my blog.
Yeah, love it. I think I've read all of those except the Edison one, so I'll have to go back and dig into that one.
Great.
Thanks for listening. If you like the show, the best thing to do would be to send it to one of your friends who also likes podcasts. If you want more, I have an email list where I send out a weekly update with all the podcasts I've recorded and articles that I've written. I also include my favorite things that I've been reading or listening to as well. You can sign up for that at www.toddneve.com. That's I before E, or you can open up the show notes in your podcast player and click the link in there.